to Decaf-Math ASMR, and a warm welcome if you are new here. I hope that you're taking care at this time. Today's video, just a heads up, might have more background noise than usual, just ambient traffic noises, though I will try to edit out any sudden loud noises. But I still wanted to make this video at this time, just because I was made aware of an ASVAB test coming up. ASVAB, which is the Army aptitude test. And it was kind of last minute, but even if the sound is not ideal, I mean, there's always a little bit of background noise and stuff, but I'm just filming at a different time of day in hopes to still send my love and support to anyone taking this test. I'm not sure if there are standardized dates for this, the ASVAB, like there are for the SAT or GRE, but either way, it sounded like this was coming up like in a matter of days, or a day really, so either way, I hope that this is still relaxing in general, that the questions are still kind of interesting to think about, but you know, if we're back to the extra sleepy videos, I normally would do my best to try to minimize the sound more. But anyways, I thank you for being here, and basically I wrote down, I think, like 4 or 5 questions here. There's a section on the ASVAB that's called, I guess, arithmetic reasoning, or arithmetic reasoning. I think arithmetic reasoning makes more sense, but both actually apply because they involve arithmetic. But it's more like the reasoning part, the word problems, and setting up questions. So that's what we're going to focus on today, and I'll just kind of try and share any tips or suggestions along the way, just whatever comes up. And more than anything though, I just hope that this blesses you. I'm praying for you, sending love and support as you study, and I thought that word problems were a good thing to include on this channel anyway, so I'll be doing more of this in the future as well. But yeah, so let's take a look. I wrote down the questions by hand. I changed up the numbers and kind of switched around scenarios a little bit, but I wanted to stay pretty true to the practice problems that I saw. I didn't have a lot of time to put this together, but I'm not very familiar with the ASVAB, so I wanted to kind of follow something. But you know that I'm very careful to not just work through specific like pre-made homeworks and stuff, because I'm not sure about copyright stuff, so I'm very careful with that on this channel. So I take extra time to kind of switch around questions or make up my own, or both, but I don't really use like textbooks or anything directly, so that's why they're on sheets of paper like this. So let's take a look for this first one. There's no particular order, but let's see here. And of course, if you have a resource for practice tests or anything that you want to comment, if you happen to be taking it, you can leave it down below, and maybe other people in the future can come back and look through the comments and refer to any resources. So, okay, so let's go. John borrows $3,000 from a bank with a yearly interest rate of 7.5%. If John pays off the entire principal plus interest the first year, how much will John pay the bank? So, if you are struggling with these kinds of problems, when you just have a word problem like this, the first thing I would do is to determine if you are struggling with turning the question into a math statement or a math problem, or if you're struggling to actually do the math itself. So if you have like a question like this and you have, 4 choices to pick from and you're getting the wrong answers, there's a lot of places that things could go wrong, right? It doesn't mean that you're stupid. It doesn't mean that you're terrible at math. It could just be one little step. So I hope to encourage you in that way. And so really, maybe you're great at doing the calculations or carrying out the algebra, but you didn't translate it quite properly. Or maybe you just don't even know where to start because you don't know how to, make math expressions from the problem. So keep that in mind. Take it step by step. And so the next thing I would say is look for the numbers and what they mean and these words. So John borrows $3,000 from a bank. So the verb, it's not a grammar lesson, but borrows $3,000. So you can annotate what you need to, but borrowing $3,000 from a bank with a yearly interest rate of 7.5%. So yearly, so every year, interest rate of 7.5%. So for an interest rate, that means if you were to return the money, so borrowing, meaning bank gives John $3,000, the interest rate means that when John pays the bank back, he needs to pay 7.5% of $3,000, however much he borrowed, in addition to the original amount. So he has to pay for having borrowed it. So if John pays off the entire principal plus interest, so the principal being $3,000 plus interest the first year, how much will John pay the bank? So having it just be after the first year means that we only have to deal with this once. So if it were, by the 4th year, you would then have a completely different question. You'd have to deal with, is it compounding interest? Is it just, yearly like that? But we're just going to focus on the first year. So that just means one iteration of this. So how much will he pay? The principal is $3,000. The original $3,000 back. So this is the original. Plus whatever the interest is. And the interest is 7.5% of 3,000, which we can calculate. Okay, so conceptually, this is turning the words to the basic math idea, right? The original principle plus the interest, which is the 7.5%. From here, we're doing the calculations, right? So how do you calculate 7.5% of 3,000? That would be, this is the math part, that would be moving the decimal point 1, 2 to get a percent, divide by 100, so that would be 0.075 of, meaning times 3,000. And you can do this on your calculator. So 0.075 times 3,225. If you can't use a calculator, you can just notice, you would do this by hand, but you might notice 1, 2, 3 zeros here, so 1, 2, 3, and just end up doing 75 times 3 on this slide. You don't have to be dependent, so 3 times 5 is 15, 3 times 7 is 21, plus 1 is 225. So you don't have to be dependent on your calculator, but if you're allowed one, you might as well just use it. So 225 is the interest part, and so the total amount would be 3,000 plus 225. So that's $3,225. Okay. So that is just if you're trying to do the calculation straight across. If you've learned other tricks, for instance, you might notice that from this you can actually factor, so it's a little bit redundant to have to do 3,000 plus 0.015 times 3,000. So you could factor out a 3,000 first. So 3,000, and then 3,000 goes into 3,000 once. Plus 0.075, right? So we actually just did a video on the greatest common factor in factoring. So this would be one situation like that. So you would do 3,000 times 1.075, which ends up being the same thing. Mathematically, these are equivalent. 3,000 times 1.075 is 3,225. So the thing is, I think what ends up happening is sometimes you'll see an explanation like this just to memorize 1.075 times 3,000, and sometimes you'll see an explanation like this. Find your original principle, find your interest, and add them together. Now you can see mathematically they are equivalent, but if you're focused on memorizing the steps, then it might lead to a bit of rigidity there and not being able to then apply it to a question that's slightly different. So what I suggest is first understand what the question is asking. So this is the, brute force way of doing it. Literally saying the entire principle and then plus interest. So have your original principle, have your interest, calculate that, and add them together. If you've seen this trick, it's just basically 1, so your original principle, so 1 plus 0.075%, and then you do that together times the 3,000. Either way, you get $3,225. So in order to borrow $3,000 from the bank, John actually ends up needing to pay $3,225 at the end of this year at this interest rate. Okay? Doing great. Doing great. Okay. So now let's look at this next question. There are 4 siblings in a family. Ashby is 3 years younger than Hannah and 2 years older than Joe, who is the youngest. Tina is the oldest and is twice the age of Joe. If all the ages totaled is 37, how old is Ashby? Okay, so when you have a bunch of names and stuff like this, we want to make sure we think of it as a unit, right? So Ashby, Hannah, Joe, we're talking about ages here. So this would be like an algebra question. But even if, we don't know that ahead of time, let's pretend we have a blank slate. We're reading this, right? When we're reading it in a book, it's like, okay, cool. Somebody's older than this person, someone's younger than this person. In math, we want to gather the information. So there are 4 siblings in a family, okay? So we can, now that we know the names, we can call them A, H, J, and T. And then now we want to gather the information. So Ashby is 3 years younger than Hannah. So let's let A equal Ashby's age. Ashby's age. H, J, T, B, Hannah, Joe's, and Tina's ages. Okay? So specifically, let these be the ages. So Ashby is 3 years younger than Hannah. What does that mean? How do we translate that? Ashby is, or is equal to, or Ashby's age, not Ashby. Ashby's age is equal to 3 years younger than Hannah. So if Hannah is, let's say, 6, Ashby would be 3 years younger than that. So 6 minus 3. If Hannah were 27, Ashby would be 27 minus 3, which is 24. If Hannah is 99, Ashby is 96. So whatever age Hannah is, Ashby is 3 years younger. So I translated 3 years younger to H minus 3. And you can do the same thing for 2 years older than Joe. So Ashby is 2 years older than Joe. So whatever Joe's age is, she's 2 years older. So J plus 2. If you're not sure if you want to do a minus or a plus in any given situation, just try out a number. If Joe is 5, Ashby is 2 years older than that. 5 plus 2 is 7. And then Joe is the youngest. Tina is the oldest and is twice the age of Joe. Twice the age of Joe. So you want to know how to translate these phrases here. You'll get used to that. I will link another video that I have on just key concepts for the basic operations like times, divide, add, and subtract. Just key words or concepts that each operation kind of represents. So we have this, and then if all the ages totaled is 37, how old is Ashby? So if all the ages totaled, so Ashby's age plus Hannah's plus Joe's plus Tina's is 37. And then the question is, what is A? How old is Ashby? So there you go. We translated this into this. So now we look at this, and now it's time to do the math. So, good job. Now in order to do the math, really we have 4 equations with 4 variables. Now, here's the thing. We're trying to solve for A. So it kind of seems like if we could substitute this entire thing in terms of A, we can use algebra to solve for 37. We don't need to solve for H, J, or T. We could just to check our answers, but the question is for A. So let's look at this. It might be helpful to translate H in terms of A as an expression in terms of A, J in terms of A, and T in terms of A. That way we just have one statement in terms of A. So what do we know about Hannah's age? Well, A equals H minus 3, right? Ashby is 3 years younger than Hannah, which means Hannah is Ashby's age plus 3 years older than Ashby. So if we make everything in terms of Ashby's age, so either you look at that and say 3 years younger than Hannah, and you can do that in your head, that means that Hannah's 3 years older than Ashby, or you look at this and translate the algebra, so that means H minus 3, you add 3 on both the sides, or if you're more comfortable, you just move the negative 3. Either way, you get these cancel. So Hannah is Ashby's age plus 3. So H is A plus 3. Same thing for Joe. Ashby is 2 years older than Joe, which means Joe is 2 years younger than Ashby, moving this plus 2 over. So Joe is Ashby's age minus 2. And then we know that Tina is twice the age of Joe, not Ashby, but Joe, which is interesting. But we know that Joe is 2 years younger than Ashby. So plus T, which is 2 times Joe's age, which is A minus 2. And the reason I did the double sort of substitution there is because we want this expression all in terms of Ashby's age, A, so that we can work with that algebraically. So let's take that and simplify it. So A plus 3 plus A minus 2 plus, and then here we would do our distributive property. We distribute the 2, so 2A minus 2 times 2. That's how we handle that parentheses. So 2A minus 4 equals 37. Now we combine like terms. So we have 1A plus another A is 2A plus one more A is 3A plus 2A is 5A's. And then we have 3 minus 2 is 1. Minus 4 is positive 1 minus 4 is negative 3 equals 37. So from here we can add 3 on both sides or move the minus 3 over. So 5A equals 40. 37 plus 3 is 40. And then we divide by 5 on both sides. A equals 8. So we know that Ashby is 8 years old. So if this part is confusing, this is a little bit of practice for solving one equation with one variable that involve multiple steps. I do have a video on that, but we can definitely come back to this. If this is what's confusing you, then it's definitely the algebra side of things. If this is the part that was tricky, then I would say take it step by step and get extra practice on this. And if it's both, then be very patient with yourself. Take your time. You've got this. We can review concepts. You can check out my videos if you need extra help. Let me know. But I'm just hoping to kind of untangle our mess here, because sometimes we just think that we're bad at math, but it's just, I say this all the time. So one great thing about these questions is you can do a quick little, check here. We can make sure we got the right answer, or at least kind of increase our consistency and accuracy. But if Ashby's 8, you can just go back and check that it satisfies all of the stuff. So if Ashby is 8 and she's 3 years younger than Hannah, that would mean Hannah is 11. And Ashby is 2 years older than Joe, so that means Joe would be 2 years younger than 8, so 6. And Tina is the oldest and is twice the age of Joe, so Tina Tina is 12, right? Joe is 6, so Tina is 12. So, and Ashby is 8. And so we total this up. The total should be 37. So 8 plus 11, I'll just do it this way, plus 12 is 20, plus 11 is 31, plus 6 is 37. So it seems like it's good to go. Good work. Alright, now a bouquet of flowers is made up of 4 lilies, 5 daisies, 2 roses, and 3 tulips. If Anna has 21 lilies, 17 daisies, 12 roses, and 21 tulips, how many complete bouquets can Anna make? Okay, so this tells us what a bouquet of flowers is made of. So we need 4 lilies, 5 daisies, 2 roses, and 3 tulips. This is how many she actually has, and we want to find how many complete bouquets. So we don't want to ever have not multiples of these. Like if we had 7 daisies, you can only make 1 complete bouquet if you had all the rest of the right ratios. So again, instead of memorizing concepts, there's little tricks and tips and different ways to solve this kind of stuff. Really, we want to focus on the reasoning, especially for this ASVAB, right? It seems like we want to focus on the arithmetic reasoning. So as long as you justify your thought process, that's probably more important than anything else. So if Anna has 21 lilies, you can do this different ways, but let's look at the limiting factor in this case. So, if you had 8 lilies and 8, 10, 4, and 6, that means you would have 2 complete bouquets. So if we have 21 lilies, that means we can make 5. So 21 are for lilies. If we have 21 lilies divided by 4, that would be 5 complete lilies, 5 complete, and we don't care about the remainder. It doesn't matter, right? So 21, if you're going to do this on your calculator, but you don't need it, 21 divided by 4 would be 5.25. We don't care about the remaining lily. We only want to do how many full bouquets can we do. So then we have daisies. For daisies, we have 17 of them, and it takes 5 to make a bouquet. So that would be, what's the largest number that number of times 5 goes into 17 without exceeding, 1, 2, 3. 3 times 5 is 15, but 4 times 5 is 20, so 3 complete, plus remaining, we don't care. With 12 roses, and it takes 2 roses to make a bouquet, so 6 complete. And 21 tulips. So 21 tulips, and it takes 3 to make a bouquet, so that means 7 complete bouquets. When I say complete, I just mean bouquets, right? Out of just, well, there's no remainder actually, but out of just what we have here. So we can make 5 complete bouquets out of the lilies that we have, 3 bouquets with the daisies that we have, 6 bouquets with the roses that we have, and 7 bouquets with the tulips that we have. Assuming that there are no limiting factors, that means that daisies is the limiting ingredient, so to speak, because we only have enough daisies to make 3 complete bouquets. So we can't just say 7 bouquets from tulips because we don't have enough daisies to support that, right? So we would have 3. So you take the smallest one. So that means 3 complete bouquets. So this is something that you could reason through just from trying to look at that, how many full ones can we make, and there's no real, no real need to like memorize, always divide this, always do this, because in the long run, we will get very confused. And I think this is why a lot of people end up hating math, because we're so caught up in specific applications rather than, having fun with it and having the general idea. So, I hope that this is helpful. Okay, last one, I think. If the senior class at a college has 800 students and 4% are majoring in math, how many students are not majoring in math? So, again, you can just see, like, my habit is always just to kind of go, whoop, 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 what's important? So you have a senior class at a college. It has 800 students in total. 4% of them are majoring in math. How many students are not majoring in math? So there's, multiple ways to do this, of course. You could figure out how many are majoring in math, which is simply 800 students and 4% of 800. So first, from the wording to the statement, to the math statement, this would be number majoring in math. And then you want to know not majoring in math, so 800 minus the number majoring equals not majoring. The rest of them, right? In math. So again, just even without the numbers, this is the concept, right? You can break it down step by step like this. If you're more comfortable with that, you can just go ahead and calculate. So 4% of 800, 0.04 times 800. With the calculator, you can plug that in. 0.04 times 800 is 32. Without a calculator, you can notice I have 2 zeros here, so I move 1, 2. 4 times 8 is 32. And then, so this would be the number, so 32 of the 800 are majoring. So if you're struggling with that, then that means that you should go back and review percents. What is 4% of 800 and how to calculate it? And why is it this? Okay? And then that means that the number that are not majoring is 800 minus 32, which you can do on the side or on your calculator. 768 are not, and that would be the answer to your question. 768. Or you could notice, if you're more comfortable with percents, if 4% are majoring, then 96% are not. 100% would be all of them. So if 4% are majoring, then 96% are not. And then you can just do 96% of 800. So 0.96 times 800. And let's just go ahead and check that. Oops. 0.96 times 800. 768. So either way, whatever conceptually makes sense to you is the way you should go. So you're doing an awesome job. I would say when you take any practice tests, if you get time to do that today or coming up if you're studying for the ASVAB, I would say as you work through practice questions, there's no way kind of getting around just getting used to what to expect. I would say just pay attention to whether or not it's your calculations that's getting you stuck or the actual translation part. And then when you kind of, I think half of the process is kind of honing in on what needs to be reviewed or studied or relearned. And from there, I think you'll be good to go. Let me know if you have any questions about this stuff. And I will in the future work through more kind of questions like this and kind of take our time with each of these principles with percents and stuff like that. I think, a really old video with percents, but you can search for some of the algebra concepts that we've talked about today. But in total, this was just a quick sort of overview, especially for our friend or friends here who are taking the test coming up in just a few days. So, much love and support. May God bless you, and good luck with it, and I will talk to you very, very, very soon. And for everyone else watching, thanks for joining me and bearing with the background noises and stuff, but we will come back for more math very, very soon.